Hello and welcome to this video on data structure and algorithms. In this video, we will look at a better Hashmap implementation. Till now, we have implemented several data structures like linked list, doubly linked list, binary trees, graphs, and so on. Almost all the implementations are good with the exception of Hashmap. Our Hashmap is not good because it will simply not work when there will be large number of members in the Hashmap. Theoretically, we have covered, but practically those Hashmaps which we have covered will not work out. Particularly if you want to do real world programming, it will not work. So I found this Hashmap on GitHub. It is in the repository of tidwall/hashmap.c. So this is a very good Hashmap implementation. We will not go through all of it, I mean the source code of it. We will not go deep into the design of Hashmap functions. We'll just take a look at uses and how the Hashmap has been designed. So the reason for not covering the internals of this Hashmap in great detail is because I have not yet covered design of Hashmap functions. Once I have covered Hashmap design, hash function design, we will revisit this and actually look inside these hash functions, that is zip hash, murmur hash 3 and access hash. So the features of this Hashmap are open addressing, and it uses Robinhood hashing. It supports a generic interface for variable side items. These three Hashmap functions, and you can add even more algorithms. Supports C99 and up, supports custom allocators, and the performance is pretty good. So we look at the example. So you have str.h, string.h, and hashmap.h. A user structure has been created with a name and age member. Now you need to implement three different callback functions which it will use. One is for comparison. Comparison takes three arguments, A, B, and new data. You can name them, of course, in a different way. And you have to provide the comparison function. So in this case, what it does is it casts the void pointer A and B to the user pointer, and then it compares the names. For iteration, it casts the item argument to user, and then it prints the name and age and returns true. For hash, it is using Hashmap zip. It gives three arguments: name, length, seed 0 and seed 1. So you have to provide seed 0 and seed 1. We'll see how these are provided in a bit. So in the main function, the first thing you need to do is you create a name, create a hash map. That is done with Hashmap new. You give the argument how many bytes you need for the user. You will see all other arguments which we need here. 000 does not make any sense right now. We have two callback functions, user hash, user compare, and the remaining two arguments are also null. Then you set the Hashmap set is called. So one of the arguments is map. You give map to it, and you provide the structure with the name and age. Okay. Then we declare a variable here with the struct user, and we try to get the user from Hashmap by using the function hashmap_get. So it takes again two arguments, map and the name of the user. Okay, name is the main key here, and once it gets it, it prints the name and age. Similarly, it tries to find other users, and of course this will fail. Okay, because the reason is we won't have this user. Okay, so user will be null. So a ternary operator has been used to print not exists. Then it iterates over all users. It calls hashmap scan function, takes map, and user callback is passed to it, and the last argument is null. We'll see what all these arguments are. Now, in a loop, how you iterate is after scanning is you have size underscore t iter and item, and you call hashmap iter on map iter and item. So the item you assign to user, and then you print the name and age. And finally, you need to free the hash map so that you don't have memory leaks. So here's the output of all the function calls we have. So what functions does it provide? We have hashmap new, which you have seen, which will allocate a hash map. Hashmap 3 will free the memory occupied, count will give number of items, set will set an item. It can either insert or replace. If it replaces, then it returns the previous item. Then we have get it, delete to delete an item, delete also returns the item. Clear will remove all elements from the hash map. Note that clear will not delete the hash map, that is, the map can still be used to insert more items. We have iter and scan. Iter is loop based and scan is call based, so it will iterate over all. So there are two hash helpers, hashmap zip and hashmap murmur. Okay, now we can read this. The important point here is it is not thread safe. Okay, the locking has to be at our level. The hashmap internally is not thread safe. The reason is it is not sufficient to add the locks to the hashmap code itself. Remember that hashmap calls return pointers to internal structures which can become invalid after subsequent calls to hashmap. If you add a lock inside the hashmap function, by the time a pointer is returned to the caller, the pointer may have already been rendered invalid. Should lock before the call, make the call, copy out the result, and unlock. So now let's get into a bit of code that how it is implemented. Note that it is licensed under MIT, so you can freely use it in your code for professional projects or commercial projects. This is the hashmap header, and we have a structured hashmap, and the arguments you can see here are given. The element size, cap, seed 0, seed 1. Okay, callback functions, hash, compare, to free the element and view data and all. We can have hashmap with new allocator where you will pass the allocator as well to it. Now in the allocator initially we have realloc and free. We have hashmap free, clear, count, out of memory. It will return boolean, get, set, delete, probe, scan. So we'll see all this. These three are the hashmap hash functions, and there are other helper functions as well which are not really used as a user. Let's look at the source code. Now, one of the things you need to look at the source when you look at the source code is you have to be careful. Below line 780, it is tests and benchmark results. Okay, so we really don't need to look at those. Instead, we should look at the code above 780. So if you look at these three functions, hashmap zip, what it does is it creates a value for the given data using zip hash 2-4. It internally calls zip64 and murmur. Murmur calls mm86128 and access hash 3 calls xsh3. So if you go to these functions, you will see that the algorithm is implemented here. This is the whole implementation of zip64, for example. So it will not make sense to go through this, that how it works or why something is done, because we have not studied the hashmap function. If you want to look at it, hashmap function, you can find it on internet. And similarly, we have MM86 128, that is murmur hash function. And then we will have XSH3. So XSH3 is implemented here. Once again, lots of bitwise kind of algorithm is implemented. There is uses of prime numbers and so on, which are common in cryptographic functions. The primes are declared here. There are 5 primes for XSH3. So these 3 are your main hash functions. Okay. Now let's look at other functions a bit. So one of the important things is you can set an allocator. The default allocator is malloc and free. Okay. You can use something like jmalloc or tcmalloc, but for the sake of that, our implementation, that does not matter. We are not going to do a max optimization for this. We have a bucket and the structure has these many members. So there are several parameters here: malloc, realloc, free, element size, cap, seed 0, seed 1, and so on. You have the hash function, you have compare, free the element, view data, bucket size, number of buckets, count, and so on. There are standard functions to clamp the load factor. We have not yet discussed the load factor, so we'll skip this. So we want to look at a hashmap set. Okay. So this is the new with the allocator. We want to look at hashmap set, that's how it works. First we look at hashmap new. So when a hashmap new is called, what it does is we have this argument. So it calls hashmap new with allocator, and first 3 arguments are null. So if you look at first 3 arguments, those are malloc, realloc, and free. Okay. Now those arguments are null and rest are specified here. Okay. So we have seen the hashmap new function over here. Yeah, here. So we have the element size. Okay, that is the element size. These 3 arguments were 0. So cap, seed 0, and seed 1 are 0. Then we have hash, compare, hash, and compare. And to free the element and new data, both are null. Okay. So that's how it calls the hashmap new with allocator. So it does several things, initializations and those kind of things. We will not bother with the implementation of that. We look at hashmap clear. So what it does is it sets the count to 0 and it calls free elements on map. The free elements goes through all the buckets, and for all the buckets it calls bucket at. So then it calls bucket at 0, and then it frees those elements. So we were looking for hashmap set. Yeah. So it tries to find the hash, which hash we are going to use. So in this case, we don't have our hash defined yet. We have not passed a hash algorithm here. Okay. So our hash function is user hash here. Now what it does is it takes the map, it takes the item from hashmap set, map and item. Okay. And then it gets the hash from the map. So get hash is, it will, from the map, it will take the key and seed 0 and seed 1, and then it calls clip hash. So it returns the hash and ANDed with all ones. So the hash is set at this function. Okay, let me find out the algorithm for us. Okay, yeah, sorry. So the hash function is set here, hashmap set. So if you look at hashmap underscore set, so this sets your controlling hashmap algorithm. So if you set hashmap murmur or access hash 3 over here, then it will control the hashing function. So that's how you set. Now I'll stop here and I will implore you to go through this source code. And if you are feeling curious, you can go and read up on hash functions, these 3 different hash functions, and probably you can find even more hash functions on internet. So this hash map is something which we will use for solving the problems which have the nature of competitive programming. This will be our default hash map in this series of videos henceforth, unless there is a specific requirement on hash map implementation. So I hope that you have enjoyed this video and found it useful. And don't forget to subscribe the channel, and so that the video spreads to more users like you, because that's how the YouTube algorithm works, that the more subscriber mean it goes up, and the video becomes reachable to more users. So help your friends by subscribing the video, liking the video, and if you have questions or comments or suggestions, or you just want to talk, then make use of the comment box. Thanks a lot for watching. Have a nice day.